Yep. Back at it.
Hello again. It's been a hot minute, and that's because I may or may not have gotten distracted with a project a couple months ago. Here's the old 3D printer that I built.
What the fuck is this piece of shit?
With that little side quest out of the way, it's time to actually get working on this project. The end goal of this is to eventually make liquid nitrogen, most likely from a Joule Thomson cooler or something similar. In order to actually make something good like that, I decided to make something simple, basic, and rudimentary from an old ice maker. The first step of that is to get the old refrigerant out of it, which is butane. Yes, they are filled with butane. After that, I took out all the components and laid them out here, and you can see the compressor on the top, then there's the radiator on the right there, and then under that's going to be the filter dryer, and then there's a fill port with a Schrader valve, which is just your bike pump valve. Then there's going to be the needle valve, which is going to be my flow restriction, and that copper coil is going to be my evaporator, which I'm just going to use to test. Then it was on to leak testing, and the big issue was all the flare fittings that I was using had a bunch of leaks, because knowing now I'm not going to use Teflon tape anymore, I'll use silicone caulk for that. Basically all the bubbles you see are leaks of propane, which is the refrigerant I'm using. After the leaks were sealed up, except for a couple very tiny ones, it was time to start testing this. You can see the Schrader valve being adjusted, which adjusts the high side pressure, which then adjusts the pressure drop, which then adjusts how much of a temperature drop there is. Because of the small leaks happening, you can see as I'm having a complete skill issue measuring this temperature, how the frost is slowly receding away, because the compressor is warming up and also refrigerant is slowly leaking out. I decided to try again, so I filled it up with some more propane, and you can see a really nice frost layer starting to form. It's also really fun to watch the frost go away after turning it off. Due to the compressor overheating too much, I tried to find a bigger one, and the one that I found has a locked rotary amperage of 7 amps, and they normally run at about 20% of that, so 1.4 amps for this one. And 120 volts at 1.4 amps is 168 watts, and with a coefficient of performance of 3, which just means that for every watt of power you put in, it moves roughly 3 watts of heat. That's 504 watts of cooling. Normal AC units have roughly 15,000 BTUs for a portable air conditioner, and that's roughly 4,400 watts. So that compressor won't work.